Let us switch gears. Question 1 starts now. Quick check. How can a solutions architect ensure that all objects uploaded to a specific Amazon S3 bucket are encrypted by default using server-side encryption? Select one answer. Review the answer choices on screen. The correct answer is option B. Default encryption is a bucket property, not application code. Amazon S3 supports default encryption at the bucket level. By enabling this feature in the bucket properties, you can specify that all new objects uploaded to the bucket, if not otherwise encrypted by the client, will be automatically encrypted using either server-side encryption with Amazon S3 Managed Keys, SSE S3, or server-side encryption with AWS Key Management Service, SSE KMS. This ensures all objects are encrypted at rest without requiring changes to the uploading application. Hey guys, ready for another round? 10 questions today on S3 and KMS encryption defaults, AZ local NAT design, and cross-region disaster recovery. 6-second timer per question, then the answer, and a short explanation. Pause anywhere you want a longer think. Good luck. Track your correct answers. You will want your score for the wrap-up. Let us switch gears. Question 2. The answer hinges on one qualifier. Org security policy needs to limit access to specific services or actions in all AWS accounts belonging to a large organization and AWS organizations. The solution must be scalable and centrally maintainable. What is the best approach? Select one answer. Review the answer choices on screen. The correct answer is option C. SCPs enforce guardrails that per-account IAM policies cannot. Service control policies, ACPs, are a core feature of AWS Organizations designed for central governance. SCPs allow you to define permission guardrails that apply to all accounts within an organizational unit, OU, or the entire organization, if applied at the root. By creating an SCP that denies access to specific services or actions, you can enforce these restrictions centrally and scalably across all current and future member accounts, without needing to configure IAM policies in each individual account. Alright, question 3. The condition is doing work. Student Records Global, an online learning company, is migrating to AWS. They maintain student records in a PostgreSQL database and need the data to be available and online across multiple AWS regions at all times. What solution meets these requirements with the least operational overhead? Select one answer. Review the answer choices on screen. The correct answer is option D. Least overhead points straight to the managed replication service. Amazon Aurora Global Database is designed for globally distributed applications, allowing a single Aurora database to span multiple AWS regions. It provides low-latency global reads and disaster recovery across regions with managed replication. This significantly reduces the operational overhead compared to setting up and managing manual cross-region replication for PostgreSQL, while ensuring data is available across multiple regions. Alright, question 4. Map the qualifier to the answer. Custom App Secure has an application with embedded credentials to access an RDS MySQL DB. Management wants to enhance security with minimal programming effort. How can a solutions architect achieve this? Select one answer. Review the answer choices on screen. The correct answer is option C. Minimal programming effort means one SDK call, not custom rotation code. AWS Secrets Manager is designed for securely storing and managing secrets like database credentials. Applications can retrieve these secrets at runtime using the AWS SDK, which typically involves minimal code changes to fetch rather than use embedded values. Crucially, Secrets Manager supports automatic rotation of credentials for RDS MySQL, enhancing security by regularly changing passwords without manual intervention or significant programming effort for the rotation mechanism itself. Okay, question 5. Identify the business need first. Real-time query ingest SO uses a fleet of EC2 instances to ingest JSON data from on-premises sources at rates up to 1 MB/s. If an EC2 instance reboots, in-flight data is lost. The data science team wants to query this ingested data in near real time. Which solution offers near real-time querying, scalability, and minimal data loss? Select one answer. Review the answer choices on screen. The correct answer is option D. Kinesis holds data across AZs before your consumer even touches it. Amazon Kinesis Data Streams is designed for ingesting and processing large volumes of streaming data in real time. It provides durability by replicating data across multiple availability zones. Amazon Kinesis Data Analytics allows you to run SQL queries or use Java Scala with Apache Flink directly on data in Kinesis Data Streams or Kinesis Data Firehose in near real time. This combination provides a scalable solution for ingestion and near real-time querying while minimizing data loss due to Kinesis's durability. Bucket defaults, org-wide SCPs, and Kinesis durability all follow one pattern. Configure once at the right layer, protect everything downstream. Here we go. Question 6. Look for the answer that fully satisfies it. CertCrypt Inc.'s containerized application on EC2 needs to download security certificates before communicating with other business applications. They require a highly secure solution to encrypt and decrypt these certificates in near real time and to store the encrypted data in highly available storage. Which solution offers the least operational overhead? Select one answer. Review the answer choices on screen. The correct answer is option B. Secrets Manager stores secrets. KMS encrypts data, different jobs. AWS KMS provides a secure and managed service for creating and controlling encryption keys. By using a customer-managed key in KMS, the application on EC2, via its IAM role, can perform cryptographic operations like encrypt and decrypt. Storing the encrypted certificates on Amazon EBS volumes provides persistent and highly available block storage. This approach offers strong security with managed key services, minimizing operational overhead for key management. Here we go. Question 7. The setup controls the answer. Auto Scaling Inc. is designing a VPC with public and private subnets using IPv4. For high availability, there's one public and one private subnet in each of 3 availability zones. An internet gateway serves the public subnets. The private subnets need internet access for EC2 instances to download software updates. How should internet access be enabled for the private subnets? Select one answer. Review the answer choices on screen. The correct answer is option B. One NAT gateway is one failure point. Always match your AZ count. For high availability and to avoid inter-AZ data transfer costs for NAT gateway traffic, the best practice is to deploy a NAT gateway in each availability zone where you have resources and private subnets needing outbound internet access. Then, configure the route tables for the private subnets in each AZ to route internet-bound traffic. 0.0.0.0.0/0 to the NAT gateway in the same AZ. This ensures that if one AZ's NAT gateway fails, resources in other AZs are unaffected. Let's slow down here. The NAT gateway count decision trips up a lot of exam candidates. Imagine your EC2 instances live in private subnets. No public IP, no direct internet path. They still need to pull software updates. That's what a NAT gateway does. It sits in a public subnet and handles outbound traffic for your private instances. Now say you have 3 availability zones. You put one NAT gateway in AZA only. AZA fails. Now every private instance in AZB and AZC is also offline, even though those zones are fine. That's the trap. The correct pattern: one NAT gateway per AZ, each routing its own AZ's private subnets. That way, an AZ failure stays isolated. The exam rewards knowing the high availability pattern, not just that NAT gateways exist. Here we go, question 8. Choose for this case, not every case. Global App DR runs a web application on EC2 instances behind an ALB, with data in Amazon Aurora, all in one primary AWS region. They need a disaster recovery, DR, solution allowing for up to 30 minutes of downtime and potential data loss. The DR infrastructure should not handle load when the primary is healthy. What DR strategy is suitable? Select one answer. Review the answer choices on screen. The correct answer is option D. Warm standby keeps infrastructure live at minimal scale, not full load. This describes a warm standby DR strategy. Deploying the application infrastructure, EC2 ALB, in the DR region at a minimal scale, or ready to scale, keeps it prepared. An Aurora global database allows for low latency replication to a secondary cluster in the DR region, which can be promoted if the primary region fails. Amazon Route 53 health checks can monitor the primary region and automatically failover DNS to the DR region's ALB. This meets the RTO RPO requirements while minimizing active resource usage in the DR region during normal operations. This one is about knowing your DR tiers, because the wrong answers look plausible until you check the clock. Imagine you're on call at 2 a.m. when the primary region goes down. Your RTO is 30 minutes. If your DR plan is restore from yesterday's snapshot, you've already failed. Just provisioning infrastructure from scratch takes 2 to 4 hours. That's backup and restore, the trap hiding in options B and C. Warm standby is different. You already have EC2 instances deployed in the DR region. A load balancer is there too, just sitting idle. Aurora Global Database keeps a secondary cluster 1 second behind the primary. When Route 53 detects the primary is unhealthy, DNS flips automatically. You're live in minutes, well under 30. Pre-deployed infrastructure is the whole point. That's why answer D wins. Here we go, question 9. Look for the limiting phrase. Global App Resources hosts multiple production applications. One specific application comprises resources from Amazon EC2, AWS Lambda, Amazon RDS, Amazon SNS, and Amazon SQS, distributed across several AWS regions. All company resources are tagged with a key application and a value corresponding to each application's name. A solutions architect needs the quickest method to identify all components tagged for this specific application. Which AWS feature or service should be used? Select one answer. Review the answer choices on screen. The correct answer is option A. Tag Editor scans all regions and services in a single query. The AWS Resource Group's Tag Editor allows you to search for resources across multiple AWS regions and services based on their tags. By running a query for the specific application tag and its corresponding value, the solutions architect can quickly identify all tagged components of that application globally, providing a consolidated view with minimal effort. Next up, question 10. Let the constraints drive the choice. DevDB Access Corp has an AWS account primarily used for software engineering. This account has connectivity to the company's on-premises data center via a pair of AWS Direct Connect connections. All non-VPC traffic from the AWS environment is routed to the virtual private gateway associated with these Direct Connect links. A development team recently created an AWS Lambda function through the AWS console. This Lambda function needs to access a database that resides in a private subnet within the company's on-premises data center. Which configuration will enable the Lambda function to securely access the on-premises database? Select one answer. Review the answer choices on screen. The correct answer is option C. Lambda needs a VPC attachment before it can reach Direct Connect. For an AWS Lambda function to access resources within a private network, such as an on-premises data center connected via AWS Direct Connect, the Lambda function must be configured to run within a virtual private cloud VPC. This VPC must have the necessary network routing configured via the virtual private gateway and the Direct Connect connection to reach the on-premises network where the database resides. Additionally, the security group associated with the Lambda function, when VPC enabled, must allow outbound traffic to the on-premises database's IP address and port, and any on-premises firewalls or network ACLs must permit inbound traffic from the Lambda function's VPC CIDR range or specific Elastic Network Interface, any IP addresses. This one trips people up. Let's trace exactly how Lambda reaches your on-premises database. Imagine your Lambda function is a contractor who needs to enter a secure building, the on-premises data center. By default, Lambda runs outside any VPC, so it has no path into that building. Step 1. Attach Lambda to a VPC. Now it gets a private IP and can send traffic through your internal network. Step 2. Your VPC route table points on-premises traffic at the virtual private gateway. That gateway is the door into your Direct Connect link. Step 3. Direct Connect carries it straight into your data center with no public internet involved. Step 4. The on-premises firewall checks the source IP. It sees a VPC address and lets it through. That's the whole chain. VPC attachment is the key that unlocks every step after it. 3 takeaways from this session. First, NAT gateways must be AZ local. One shared gateway is a single point of failure for your entire VPC. Second, Secrets Manager rotates credentials automatically. KMS encrypts data but does not manage secret lifecycle. Third, Lambda without VPC config runs an AWS managed infrastructure with no path to Direct Connect or private subnets. Encryption defaults, AZ local NAT, warm standby DR, 3 patterns the exam throws at you from every angle. Internalize the principle and the wording won't matter. Before you head out, subscribe if you want the next set automatically. It also helps the algorithm share these. Comment how you did and which question to cover more. Got a certification you're after? Drop it in the comments. And if anything about the pacing or visuals could be better, I read all of it and genuinely use it.